Hello, RCHS pre-calculus students. So, today I'm going to talk about solving systems of linear inequalities, and then I will go over the using matrices to find the area of a triangle, which is in the notes from last time. So first we'll do this. So to solve a system of linear inequalities, you must find the ordered pair that satisfies all inequalities. So in a system of linear inequalities, your solution is actually all the points that lie in the area. So we're going to graph the inequalities, and in their intersection, in the areas where they overlap, any point within that is a workable solution, and the graph indicates all of the solutions. So to solve a system of inequalities by graphing, we will graph. So first, you want to solve for y. So 2y is less than or equal to x plus 2. Y is less than or equal to 1/2 x plus 1. So y-intercept of 1, slope of 1/2. I'm going to sketch it, of course. I should probably do better on this, but it's less than, so you would shade below. I don't shade until I have everything graphed, so I have an idea of where I need to shade. So that was that one, and now we'll do x is less than or equal to 4. So an x equals line is vertical, less than 4 is this one. So this, this is particular to this kind of, not all the equations will be like this, but this one is, the area that overlaps is these points where x is less than 4 and y is less than half of x plus 1. And it, of course, would go on forever in this direction and down, but always below this line and to the left of this line. So the solution is the entire shaded area. A system of more than 2 linear inequalities can have a solution that is a bounded set of points called a polygonal convex set. That is, when you graph the inequalities, the lines, the boundary lines cross so that they make a closed shape. And that's called the polygonal convex set. And then almost always, your solution is the area inside that shape. Some trouble with this setup. Okay. So in example 2, solve the system by graphing and name the coordinates of the vertices. So x is greater than 0. That just means we want positive x values, so it's going to be anything to the right of this line. Y is greater than 0, so we want positive y values. That's anything above this line. And 5x plus 8y is less than or equal to 40. Solve that for y. X plus 40. So y is less than or equal to negative 5/8 x plus 5. So we'll do our 5, down 5 and over 8, puts it there, or equal to, so I'm making a solid line, and it's anything below that line. Now this technically continues on, but since I know I only want the regions that are right of this line and above this line, here's my shaded area. Sorry. Just this triangle is my polygonal convex set. The vertices just means the corners, so I want the coordinates of my corners, and those are 0, 0, 0, 5, and 8, 0. And that's it. So if it says name the coordinates of the vertices, you graph the shape, you find the points where the lines intersect, and you name the coordinates, and you're done. The vertex theorem says that the maximum or minimum value of a function on x, defined on x and y, on a polygonal convex set occurs at a vertex. So that means if you have a bounded area and you're evaluating a function, both the maximum and the minimum values of that function will occur at the corners, which is great because it means that to find maximum minimums, you don't have to look for instance, every single, well, sorry, that's a bad example, but every single point in this region, you just look at the corners. So, find the maximum and minimum values of this function for the polygonal convex set determined by these inequalities. So, x is greater than or equal to 0 means you're going to be to the right of the y-axis, only the positive axis. Y greater than or equal to 0 means you're going to be above the x-axis, only positive y's. Then solve the others for y. So y is less than or equal to negative 2x plus 4. Y-intercept of 4, slope of negative 2. And I'm only going to be under that line. And finally, x plus y is less than or equal to 3. So y is less than or equal to negative x plus 3. Y-intercept of 3, slope of negative 1. And we want to be below this line. So, where's the bounded region? Should have gotten another color pen. The bounded region is this quadrilateral here. And the corners are 0, 0. That's the easiest one. Now, this point is not within the region because it's not below or on this line. So this is in the region, but that's outside of it. So this point, which is 0, 3. This point, again, this is outside the region, but this is within it. This point, which is 2, 0. And finally, this point where they intersect, which if you graphed carefully, you should see is 1, 2. If you graph sloppily, it's harder to see, so graph carefully. But we're not done, remember, because it says find the maximum minimum values. So I'm going to evaluate the function. So here are the 4 points, the 4 corners, or the 4 vertices. 0, 0, 0, 3, oops, don't know why I did that. 2, 0, and 1, 2. And I plug in to the function 0 plus 2 times 3 plus 1, 2 plus 2 times 0 plus 1, 1 plus 2 times 2 plus 1, and I get 1, 7, 3, and 6. So where's the maximum? The maximum value occurs at the point 0, 3 and is 7. So be careful about what you're being asked for. It says find the maximum values. Maximum value is 7. The minimum value is 1. Sometimes they want to know where they occur. Sometimes they want to know what they are. So in this case, they wanted to know the value. That's how you find maximum and minimum values. You graph each linear inequality, shade the region where they overlap, find the corners of that region, and evaluate your function at each corner. This word problem at the bottom is, I think, not a very good word problem, so I'm going to do another one in a separate video, so look out for that. Now, for those of you who didn't get this in class, which is almost everyone, I'm going to do this thing about finding the area of a triangle that I skipped in class, but we can do it now. It is actually exactly what it says. To find the area of a triangle, you make a matrix with your x, y coordinates along your first 2 columns, x coordinates, y coordinates, and then fill in the last column with 1. Get the determinant, cut it in half, because the determinant of this actually would give you the area of the rectangle. Cut it in half for the area of a triangle. This plus or minus really just means take the absolute value. The sign is chosen so that the result is positive. Area will always be positive. So, for an example, let us do number 2. So, to find the area, we want plus or minus 1/2 the determinant of 5, 1, 1, negative 3, 7, 1, negative 2, negative 2, 1. If you want to put this in the calculator, that's fine. If you don't, doing it by hand, remember, the element times the position sign times the determinant of the minor. So that'll be 7 minus -2. Then the element and the position sign times the determinant of the minor. So -3 times 1 minus 1 times -2. So that's a -3 plus 2. And then the element and the position sign times the determinant, -3 times -2 minus 7 times -2. So it'll be +6 plus 14. So plus or minus 1/2 times 5 times 9 is 45. -3 plus 2 is -1. Minus 1 times -1, so that'll be +1. Oops, not done yet. Plus, and then 6 plus 14 is 20. I'm sorry, it got so illegible there. So 45 plus 1 plus 20 is 66. Half of that is 33. 33 is already positive, excuse me. So the area of that is 33. So now you can do the rest of them. Number 1 is going to have a weird answer, which is just fine when you think about what this triangle would be. So after you've done number 1, if you're worried about the answer, plot these points on a graph and try and think what the triangle would look like. I'm making air quotes around the word triangle. Triangle. So you can now do this worksheet. If you want to do it in class tomorrow instead, that's fine, and we'll keep working on the inequalities. See you tomorrow.